Testing. All right. Good evening. Hey, this thing is on. Okay. Hi, my name is John Ramey. Welcome to the Austin Deep Learning Meetup. If you are here for another meetup, you're in the wrong spot. Blockchain, is there still a blockchain meetup? I don't know. I think they're over there. I don't know if blockchain's still a thing. That's what my phone tells me. All right, so tonight I'm going to be talking about AWS SageMaker, something that had a bit of an interest in trying to figure out what it was all about. Hopefully I've answered some questions. Before we get started though, my name is on the screen. I work at Novi Labs, startup here in town. We've been around for about 4.5 years. You see my Twitter handle, that's also my GitHub handle, and it's my everything handle, except for Instagram because you can't change your name. It's screwed up. I'm Ramheiser42. I don't have any pictures on there, so it's fine. All right, so let's talk about meetup business. Thanks to our sponsors. You saw the nifty screen, the splash screen at the beginning. Kung Fu AI has taken very good care of us. Thank you guys for sponsoring us continually. They've been working with us closely for about 6 months now. They are continuing to hire and grow. They're an AI consulting business and they're legit. So reach out to them, or I can put you in contact if you'd like. Also, thanks to Capital Factory for hosting. They've been a good partner for quite some time. We have some. So this month was a little bit weird. Couldn't quite get a talk, but I had a bunch of people tell me I'll talk in October, I'll talk in November, I'll talk in December. So I'm kind of filling the gap. I'm sorry, but we do need talks for November and December. I have volunteers, but I want to get those nailed down before I say that they are closed. After we're done here, we'll go across the street over here to CU29. It's a cocktail bar. Generally speaking, we have about 20, maybe 10 to 20 people that go over there. Really good conversation. I've got to know a lot of you as a result of it. Please join us. The conversations stem from everything from science fiction to what are you doing at work with this stuff, I recently heard that there was a startup that was spun out of this meetup. That was pretty exciting, right? I got to know those guys when they first joined the meetup. So when we first created the meetup, that was always the goal. So we've checked the box and we can just kind of close the doors on the meetup, I guess. We have a Slack channel. Please join. People are starting to use it more and more and more. I'm learning a lot from you guys. Special thanks to Abai, who's not here, and Daniel Mailer, who is also not here tonight. They have done an amazing job for the final thing you see, which is leading the Journal Club. So the Journal Club is the advanced group we have. It meets twice a month, last week and next week. No, excuse me. First and third Tuesdays of the month. They have recently started organizing all the papers we're going to read on Trello, and there's a voting mechanism. It's much more organized than it once was, but all of that's done via Slack and Trello. See the meetup site if you need more details, or see me after. All right, so a little bit about me. I was a nerd as a kid, nerd as an adult. Things don't really change. My background, I've been coding since I was really little. Also, I was a mathlete/athlete. Stats and computer science, been doing this for a long time. I lead the data science team at Novi Labs, the startup I mentioned a moment ago, and co-founded this meetup 3 years ago alongside of Pierce Spittler. All right, let's talk about SageMaker. How many of you have used SageMaker? Give me a show of hands. Okay. So were you here, are you guys here to hear about SageMaker, or are you here to listen to me? Just kidding. Yeah, see, Jacob's here for me. Okay, okay. So let's get a couple things out of the way. SageMaker failed miserably on me today, and hopefully, so I have a live demo, hopefully it does not fail miserably on me in a little bit. Fingers crossed. I'm not a SageMaker expert. I'll say a little bit more about this in just a moment. Actually, let's just get into it. Deploying machine learning is hard. I don't know if you've done this. As soon as you have to make a change to your model, features, data, hyperparameters, whatever, deploying machine learning is hard. In part, one of the biggest challenges is model versioning, right? You have a model, you update the model, you version it, right? So if you're doing something that's, you're rolling your own Flask app, right, that has some deployment mechanism, it's straightforward. It's just an extension of, I can do it on my own machine. The second you start working at a very data science focused organization where you have models that are being kicked out constantly, versioning those models can be very, very challenging. Similarly, keeping endpoints up to date can be hard. So there's a bunch of things that are really challenging. First and foremost, you have some kind of version attached to that endpoint, which may or may not be the same version as the model. The reason for this is because you may have some Docker image attached to it, and that Docker image has its own set of versions. Obviously, things like NumPy, SciPy, Pandas, scikit-learn, TensorFlow, the long list of packages we all care about, they each have their own version. So those are just two challenges, right? So at Novi, where I work, go back 3 years ago, we had this issue. And so there wasn't a really good answer back then. So what we ended up doing is we said, okay, all of our stack will be scikit-learn pipelines. That doesn't mean scikit-learn. That means anything that scikit-learn pipeline, I'm underscoring that, compatible. So XGBoost fits in that mold. TensorFlow can fit in that mold if you really force it. Anything that's scikit-learn pipeline compatible. So from that, you can export JSON, right? Specifically, you can serialize JSON to S3. So what that means ultimately is like you have a configuration. These are the features going into my model. These are the hyperparameters. These are all of the data transformations I wish to use. I'm going to write all of that to S3. And so we probably spent somewhere between 3 and 6 months really getting that right. And then at some point, we're thinking, oh, doesn't Docker fix everything? And the answer is no. Let me just get that out of the way. It does not. And so I heard about SageMaker a few months ago, and I was asking the question, does it make it better, right? So while we have come up with something that works for us, there's some limitations on what we have done. So in our production pipeline, we've had limitations on what kind of TensorFlow Keras things we can deploy. And so the question for us at Novi is, does SageMaker just magically fix everything, right? So that's the question I'm intending to answer. I can't tell you definitively yes or no. I'm still in my, I'm still evaluating this thing. But what I will show you is that it is way easier than I expected it to be. And then there's going to be some obvious cons, and I'll show you that in a moment. All right, so SageMaker, what is it? Here is a quote from some random Amazon slide deck, and I put the link at the bottom. It's a fully managed service that enables data scientists and developers to quickly and easily build machine learning-based models into production smart applications. That's a mouthful. And so what does that mean? Use TensorFlow, use Keras in production with data transformations. You have raw data that you're transforming, feeding into models, and keeping this managed. Now this thing, I believe this quote is from a couple years ago. They've simplified this a little bit, and really they're trying to create, they meaning Amazon, AWS in particular, are trying to create a very simple workflow for data scientists. And I was actually impressed by this, and I'm going to show you in a few minutes when we get to the demo what I mean. But the focus is on Jupyter notebooks. Like, I was actually impressed with what they've been able to do. Okay, so let's start with, here's a screenshot from some random SageMaker documentation. This will get us started, but we'll go into a little bit more detail in just a moment. All right, so SageMaker, they break pipelines into 3 buckets: build, train, and deploy. So I'm gonna go in reverse, because it's a little bit easier for me to talk about that. So deploy means ultimately, I have a model. I've come up with this model. What do I do with it, right? So at the end of the day, what the SageMaker SDK and the other things we're going to go through, what they ultimately do is enable you to have a RESTful API sitting in front of your model. That's what it comes down to, is that simple. And then there's a lot of tools built around this to make this very seamless. And those tools are built into something called the SageMaker SDK. So all that means is it's a Python wrapper around a lot of their tools to make it really, really simple to deploy and interact with various models. All right, so working backwards, so training is the thing that a lot of people, I think, what draws a lot of eyeballs to it, right? You're looking at various frameworks, you're looking at Tensorflow, you're looking at Keras, but this is certainly not limited to that. And I'll list a few things in a moment, but it includes Spark, Spark ML, Keras, I think I already said that one, Chainer, if you're familiar with that, scikit-learn, XGBoost, etc. Right, so that's a very focus on, okay, I have some model I want to train, I want to do hyperparameter tuning, etc. I want to do this at scale. So a big focus of SageMaker is scale. That includes GPU instances. Now build, the reason I went backwards is because build is probably the most nebulous. It's also probably what most of us spend most of our time doing. So they call build, and I would not say that, but I'm not a marketing person. I would say explore. And so what I mean by explore is I have raw data, I have data that I'm trying to do feature engineering, I'm trying to plot, I'm trying to identify correlations, I'm trying to look at raw data and ask the question of how can I create process data. There's another thing, and I'll mention it in a little bit more detail in just a moment. There's a major focus within SageMaker on data labeling. So if you have a lot of unlabeled data and you would like to come up with a smart way of labeling that data, there's a major focus in SageMaker on that. So those are the 3 buckets that SageMaker puts data science in, those 3, and they're trying to tackle those 3. But the mechanics of this is 4, and this is where it gets confusing because you're trying to fit 4 things into 3 buckets. But suffice it to say, you have ground truth and notebook. Those correspond to build, right? So notebook is where we're going to spend the most of our time at the end of the slide deck going through. So it's basically Jupyter notebooks, like as you know. I'm going to make the assumption that everyone here is familiar with the Jupyter notebook. If not, that's perfectly fine. Can point you to a handful of resources after. Ground truth, okay, so let's say you have a data set of images and you have 1 million images, right? And the question is, okay, you may not have labels. How do I get labels? So what you could do is you could go image by image by image and say, I'm going to add a label to it. It's a cat, it's a dog, it's a car, it's a truck, it's a helicopter. And so you could go image by image, but that's going to take you quite some time. So there is a field called, it's not as well known as, say, deep learning or reinforcement learning or all these things. It's called active learning. And the question is there a smarter way to label your images in that instance? So what SageMaker has done is taken one of the standard ways to do active learning, and you see this thing on the screen. This is a screenshot from the console called labeling jobs. So you can interact with, say, Mechanical Turk. You can interact with your own, custom Flask app, whatever. They've created a mechanism to say, here's my raw data, say the features, and I need labels. How do I make that happen? So that like ground truth feels it's very important that they've added it to it, but most of the focus of SageMaker is on the other 3, notebook, training, and inference. Yeah, Jacob. Yeah. So Jacob asked, can you tie Mechanical Turk and your own app together via SageMaker? The answer is yes, but let me be a little bit more specific. So one thing that people have used in the past is Mechanical Turk, or a lot of people do this, to label unlabeled data as via Mechanical Turk. But ultimately, you're doing either at random or you're doing some systematic sampling. What you can do ultimately is back Mechanical Turk with an active learning engine via SageMaker, and it will give those images to, yeah. Oh, that's a good question. I actually don't know the answer to it. I suspect so because, yeah, ultimately he's asking, can you label via your own app and Mechanical Turk simultaneously? Yeah, I believe the answer is yes. It seems like you should be able to. Yeah, cool. Jacob, I really don't know what I'm talking about, so we can talk, but that's good. I'm glad I'm able to provide useful information. Okay. So I've known Jacob for a long time. He and I are good friends. All right, so what kind of algorithms do you have in this thing? Well, you actually get quite a few, and this list is not exhaustive. It's not even close. I hit a jackpot a few days ago when I was looking through, starting to prep for this meetup talk, and I didn't realize how far they had taken all of the examples, all of the algorithms are out there. So start with this because this is from a slide deck from AWS. This probably, I don't know, I'm just gonna make it up. You can click the link if you want the exact date, but it's at least a year or two old. And I know that they've been adding algorithm after algorithm. But this list doesn't even begin to do this justice. So let's start with a couple of the things. The first thing you see is XGBoost and linear models. Basically what people would say as classical methods. Even XGBoost, calling that classical to me really hurts my feelings, but you get the point. These are not deep learning techniques. Again, for unsupervised or dimensionality reduction, k-means and PCA, these are just baked into SageMaker. When you start moving to the more deep learning side of things, you have convolutional neural nets. You can basically just import something and it's pre-trained, or you can do your Keras style where you freeze certain layers and you train the last layer. They make this pretty seamless. And then, of course, if you're trying to do something NLP-based, either old school LDA or something more recently, seek-to-seek, all of this is baked in, right? So Amazon has basically created a whole business line to say, I'm going to take every major algorithm out there, and I'm going to just add it as another thing. So you get it for free. You're paying for the machine, right? That's you're paying for the instance time. And I mean, I'm looking at this going, okay, somebody probably had this idea and they probably limped in with like 3, 4, 5 models. But when they really put their team on it, these guys have crushed it. And it just like, good luck keeping up with them. If this was your business model you had in mind, good luck. I mean, they've really done their homework. All right, so there's this thing called the SDK, and I'm going to say a little bit more about that in just a second. I have a link at the bottom. So which frameworks are supported? So via the SDK, the two major foci, whatever, are Apache MXNet and TensorFlow. And so one question you might ask is, what about Keras? Right now, the workaround is that you basically have to export Keras via a TensorFlow. But the way you end up having to do this via SageMaker is you actually have to do an export of your model as a TensorFlow compatible model. And then I'll get into the details in just in a little bit. So it supports TensorFlow, but it does not support TensorFlow 2.0, which is what you're alluding to. Yeah, but in order to deploy Keras via SageMaker, you have to do this export thing. They basically have their own, what they call an estimator, which is very similar to a scikit-learn estimator. And those estimators are one way you interact with your own custom model. An alternative way is, we'll go through a couple of examples a little bit later if we have time. where you have this concept of a model bundle. And so basically it's a tarball that has your model inside of it. And that model bundle is ultimately what you're producing. So if you have a Keras model, you're going to produce this thing called a model bundle, and you'll work with the model bundle. Well, I'll make that a little bit more clear in just a moment. You got way ahead of me, Jacob. I expect nothing less of you. Okay, so the SDK has direct support for a number of things. A few of I mentioned. So I mentioned, to be a little bit more specific, so Keras you have to export to the TensorFlow protobuf format. So the just .pb file. And then from that, you can produce something called a model bundle. But you see quite a few frameworks listed up here. One I was actually kind of surprised, and I don't know anything about it yet, is how Apache Airflow interacts with SageMaker, because I was actually going, okay, they've been really focused on you have some kind of data frame or you have some NumPy array and you want to feed it into one of these algorithms, or even some of the, just your standard TensorFlow workflow where you have an image and you're going to convert it to a matrix or tensor or whatever. I'm intrigued by this Airflow concept because potentially you have a ETL DAG and sitting in front of SageMaker. I don't know anything about that. I saw this probably last night. I'm pretty intrigued by that because if they nail that down, it could be quite useful. All right, so Jacob, here's a little bit more specifics. Here's a screenshot of what TensorFlow SageMaker estimators are. I'm going to click the link in just a moment, just so we can look through. So you see several supported versions of TensorFlow, including the most recent one being 1.14 and not 2.0. I ran into that as I was kind of fighting with SageMaker, only to realize they don't support 2.0. Yeah. Well, but regardless, you still have to export as the protobuf format. Yeah. I don't believe so. I don't believe so. If I'm wrong, please prove me wrong. Yeah. But, all right, so let me, so we can start looking at a little bit of code. So here's the, let me blow it up, sorry. Can you guys see that? I'm not going to go through this in great detail. I just want to point out a couple of things. So this is the text that I straight up stole that I had in the slide. So train and deploy models using popular deep learning frameworks, blah, blah, blah. I think the one most important thing is that they do just out of the box support GPU training. And if you have your own algorithms, you're able to build those in pretty seamlessly. So let me jump head to TensorFlow. So I'm not going to go into this in great detail. Knock yourself out on your own time. Oops, kind of screwed that up. So I think ultimately they have a lot of documentation. Apologies. Can you guys see that? There are a lot of different ways to deploy TensorFlow models. You can actually deploy via TensorFlow serving. If you're familiar with that, you can basically back SageMaker with TensorFlow serving, something I didn't know until last night, basically. One of the main ways you do this, though, is you end up doing something called a model bundle, and all things, like probably the most straightforward way is to produce this model bundle. So for us, all roads are going to lead to that model bundle. I'll show you a little bit more about how that works. But this documentation, I'm going to switch back to the slides now, but this documentation is very, very extensive. Like, I was really impressed. I was expecting it to be a standard Amazon thing where you don't quite know what's going on until you hit error after error after error, and you are basically Googling stack traces. But they have done a fantastic job on documentation. So a lot of what I'm doing tonight is basically summarizing a lot of those docs because that's how good they are. All right, so let's talk a little bit more about why, right? So why would you use SageMaker? So I've already mentioned a little bit about deploying machine learning is hard, right? Especially if you're in an environment where there are some certain places I've seen or I know of people who work at where they basically have one model that they're keeping up to date at all times, and that makes it a little bit more straightforward. The second you start deploying dozens of models simultaneously, hundreds of models, even more than that at times, that's when things get very, very challenging. It's very difficult to keep those organized. What features are in the model? What transforms have I applied? The whole gambit is very, very difficult. So Amazon, in their usual way, they make managing the hard parts better. Well, they don't always do it, but in this instance, so far, I'm very impressed. There's an obvious con, which is cost, and I'll shine some light on that in just a moment. It's not as simple as just have your EC2 instance running at all times, like you might have done way back. It's quite a bit more expensive than that. The other thing to note, though, is it's built for scale. Like out of the box, there are a variety of ways to scale these things. First of all, you can use your normal managed environment. Everything like Spark, everything like even Airflow, like I mentioned a moment ago, just for the data processing and feeding in, as well as just the seamless pipeline. It's just built for scale, and that does include both memory and GPUs, or I guess compute power. The other thing, hopefully I'm logged into Amazon. Okay, here we go. This is pretty interesting here. So I mentioned to you a moment ago that, can you guys see that okay? Is that okay in the back? Are you able to see? No? Let me try again. A little bit better? Okay, very good. All right, so one of the things that you'll learn very, very quickly is that there's a whole marketplace of models. So if you have a model, so there's a variety of these that people are coming up with, and you see various vendors over here on the side. So you have things like closing price of cryptocurrencies. Of course, that would be the first one. And I didn't mean to click it, but I guess mentally it was just drawn to cryptocurrency modeling because that's what I do. I don't really. So basically, you have a model you've built. You can deploy it. You can immediately hit that endpoint very easily. And you pay them a price. Let me see if I can find this. Right. That is a fantastic question. So if you're the one that deploys, I don't know exactly, like if you come up with the model and you make it available, I don't know what the cut is or anything like that, so I'm not gonna pretend like I know. But what I do know is that in several of these cases, there's a pre-baked endpoint, and you just hit that, and you pay an hourly rate. There's another instance where, let's see if it's listed here. Let me just find another one. Yeah, so basically what you end up doing, hopefully I can find this. Yeah, you see this right here? Gonna try to make this bigger. Oh, that worked. Okay, right, so you have pricing. There's several different layers of pricing. So inference means prediction, so you deploy this model, it's already trained, and you're going to be feeding data into it. In addition to that, there's also there's infrastructure cost. I believe that's what you're paying Amazon, and then the software cost is what you're paying whatever company I clicked. Now, what I don't know is, do they get the 10 cents per hour, or do they get some percentage of that? I just don't know. But there's a whole marketplace here. Knock yourself out. There's a lot of cool things that people are doing, and then there's the cryptocurrency stuff. Showing my true colors there. Let me make sure I understand your question. So when you say, can it be deployed to one server or multiple servers? So what you can do, I believe it's per instance. So I believe you can do this in parallel, right? So like you could potentially have 5 instances of the same model. In terms of auto scaling that like you would normally do, I don't pretend to know. Yeah, I think it's per hour on the instance. So if you had it running on 5 different instances, you'd pay 5 times the cost. Yes, they do. Yeah, they are heavily integrated with Lambda. Yeah. Oh yeah. Oh yeah. Okay, so finally, why SageMaker? I really like this notebook instance thing, and that's what we're going to be looking at. One is probably the most complete. I don't know. Dylan will tell me later that I'm wrong, but it's probably the most complete. I work with Dylan. Thanks, Dylan, for being a good sport. Whatever Docker image they have running behind this, their Jupyter Notebook instance, has everything you could ever want. And you would expect this giant Docker image, but somehow it works pretty quickly. So they're probably not having to download it from the cloud per se. They probably have some internal thing. Okay, so one other thing to call out here, and by no means am I trying to point to any one of these GitHub repos, but if you go to GitHub, to the AWS GitHub group or the AWS Labs, they are really working on SageMaker, right? So all I've done here is I've typed in SageMaker for both of those accounts, and you see that there's a lot of activity for SageMaker, both in terms of just raw number of repos, and you look at the contribution to both the examples and the SDK, and there's a lot going on. So my belief, just perusing these things, is that they are really doubling down on SageMaker. I believe they're just trying to tackle Google Cloud's AI engine just head on, and these guys are doing way better. It's impressive. Okay, so, yeah. Yeah. Mhm. So let me start with costs. First and foremost, like you're talking about ultimately edge versus cloud. The cloud version of this very framework is very expensive. So going on the edge or some local machine or something, that I believe is going to be very problem dependent. Just because being on the edge, usually you're limited in compute power, and often you're limited in just the wattage of whatever device you have, like if you have an embedded system or something. So you're going to be limited there. If you can do some processing at the edge, great. For a lot of cases, you're not going to be able to. Unfortunately, I think a lot of more the standard ML type problems, you're going to have to pull it up into a centralized thing. Potentially, you can have some pre-built model that you are transferring, a transfer learning type thing, which you might be able to do at the edge. But specifically around pricing for SageMaker, these are one node instance. So before I mentioned you have build, you have train, and you have deploy, or they also say inference, right? These are base costs. I just want to call out how expensive this is. All right, so what I have done here is I've taken a notebook instance, which I have one running, and I'm going to show you how to launch that and everything. And that's 26 cents an hour, right? And really at the core here, it's an EC2 instance running some Docker image that's Jupyter compatible. And so you go from a, say, 4 cent an hour to a 26 cent an hour notebook. The notebook is optional, right? But it makes it really, really easy. But you are paying for the cost. If you had this thing running for an entire month, just multiplied that by 24 times 30, and you get $187. Now, if you had a GPU instance, so notice this in the instance type here. you'll see ML, the prefix there. ML ultimately means machine learning. Amazon started adding prefixes to their instance types. So this ML P2 X large, this is the cheapest of the GPUs. Notice how expensive that is for a single node running with all of these bells and whistles. So ultimately, you're talking about 3 nodes, one simple for the user to interact with your model, one to do the training, and I'm making the assumption that you're training full-time, which may or may not be applicable. And then you have a deployment. So this is the thing that you're actually sending data, asking for a prediction. If you were running each of these full-time, you're talking about $2,000 a month. At the training level, although you may not be training 24 hours a day, you may be training multiple instances simultaneously. If you do a larger GPU instance, I think the second cheapest one is $10 an hour. So you can see how this would add up very, very quickly. So you're not just using the GPU instance, you're using the GPU instance plus all of the bells and whistles that come with SageMaker. And notice the caveat at the bottom does not include storage costs, does not include transfer costs, so that means data coming in, data coming out, and this thing called Inference Acceleration, which I don't quite know what that means, because when you Google that, all you get is a bunch of things about teraflops, and they just overwhelm you with compute power numbers, and they say you can make your compute time that much faster if you just enable inference acceleration, which for the low price of $1.28 or $2.56 per hour, you can increase the runtime speed of each of these things. So this is the obvious con. So I'm going to show you this in action in just a moment, why I think this is a very impressive thing, but the obvious con is this thing is expensive. Okay, almost done with the slides, and then we're going to go into notebook land. So I don't know if this is legible. Yeah. That's a great question, and I really don't know the answer to it. When I was trying to figure that out, that was mentioned a number of times, so I assume you're right. You're correct. So I'm assuming, I'm making a huge leap of faith here, that ultimately this is Amazon's version of the TPU that Google has. I'm going to make that assumption, but I don't quite know. You may know better, but yeah, I believe that's what's going on here. Okay, so I don't know if this is legible. Let me see. All right, so this is kind of so there's a giant PDF called the Amazon SageMaker Developer Guide. And this is straight up a stolen screenshot from there. Ultimately, you see, all right, I'm going to try to use my mouse here. Hopefully you can see the mouse. Tiny little black thing in the corner. So they're going to make the initial assumption that you have your training data in S3. You could easily have it in a database or what have you, but we're going to say it's in S3. So this is kind of like the general way you would architect a SageMaker app. So up here at the top, you have some kind of web app, you have some kind of UI, or even some kind of client or customer interacting with an endpoint. So this endpoint, think RESTful API. So what this endpoint ultimately is doing is hitting this deployment, right? So the deployment, ultimately you have 2 pieces of code. You have helper code, so these are utilities. These are things you're going to be interacting with. Generally things like scikit-learn, like some of their transformations, or any kind of thing for data processing. And then inference is twofold. One is to actually serve up a prediction, but 2 is any processing of the inputted features, any inputted data that you would receive from this client application, and you're basically going to convert that input data into a JSON blob that you're going to respond with. So let me give you an example. I'm trying to do the simple thing of classifying. I have an image. Is there a cat in there or a dog, right? And so this endpoint, somebody's not necessarily going to send me the image, but what they may do is send me a link to an image on the internet, right? That's all they send me. So what I'm going to do is this helper code may go download that image, right? So I now have that image in my own machine, And then I'm going to process that image using this inference code. So when I say process that image, ultimately transforming it to a tensor or a matrix. And then I'm going to make a prediction. This image has a cat, right? And then I'm going to respond to this client application with a cat. Now down here, this is ultimately their architecture for doing training. So you have a ton of, in my cat dog example, you have millions and millions and millions of cats and dogs. My sister would understand because she's a cat lady, crazy cat lady, right? She might have 1 million cats, maybe 2 dogs. Sitting there on S3, and she's going to feed these things in your usual way of loading images in, training cat or dog, and so on. So the general workflow is pretty similar to what most people are accustomed to. Now, how does Amazon want you to build an app? So here's an example, and this is what Jacob alluded to a moment ago. So ultimately, let's say I have a, hopefully, I'm going to make some assumptions here. Just let your eyes glaze over if you're not that familiar with some of the Amazon architecture. So ultimately, we have the Sage Maker, and their logo is this fancy-looking purple brain, right? You may have a Lambda function that's saying, okay, some event has occurred. Somebody has uploaded something. It's now sitting on S3. I have a trigger for a Lambda function. That Lambda function sends off a notice to SageMaker. This is awesome, man. So ultimately, SageMaker, you'll notice, is it gets data from S3, and it may write something to S3 as well. And it's going to interact with the rest of Amazon via Boto3. How do you say it? Boto3? Boto3? Boto3, right? And so ultimately, all things, if you notice here, what I really want to draw your attention to when you're building an app is that notice how SageMaker is at the core of this whole app, right? You have a Lambda function, something occurs, SageMaker is right there at the core of it, and all of the interactions would be via SageMaker. Previously, if you weren't doing some kind of data science thing, you were just doing something more deterministic, you would just cut out the SageMaker thing, and the Lambda function would go straight to the rest of the architecture. Yes, sir? Yeah. Let me see if I can summarize what you're asking, and please correct me if I get it wrong. Yep. Mm-hmm. Yes, so you can do as much of this outside of SageMaker as you would like. So ultimately, what he's asking is if you have a feature vector and it's mapping, say, a label, does it all have, I mean, one question you might ask is, does it all have to be in SageMaker? The answer is no. But ultimately, what SageMaker is allowing you to do is you can use SageMaker for as much as you would like. You could train that entire model outside of SageMaker, turn that model into a SageMaker compatible model, and then solely focus on deployment. Or you could also train the model via SageMaker because they make it really easy to do it, but it's also insanely expensive. So you could either go from raw data to that feature vector or that feature vector to the label, and you could train either one of those cases. You could do it via SageMaker. Third, and what you're alluding to, and I'm going to show you a little bit more like with a demo in just a moment, the whole Jupyter instance and what their focus really is, because I think that will ultimately clarify for you like what they're really trying to do. Yeah. Yeah. So here's another example. Can you guys see this in the back? If not, I'm going to zoom in an awkward way, but hopefully you can see it. So I will make these slides available. I forgot to post the link on the Meetup site. You will have these slides right after the talk or whenever I get home. Feel free to click the link. It'll take you to this example. But this is what we've been building to. So notice here, so you got the build, the train, and the deploy over here. This build piece, in case it's not legible, you have a SageMaker notebook. So ultimately, they've already replaced the name Jupyter with SageMaker. They've basically ousted the Jupyter project, which this kind of ticked me off when I saw this, because now they're taking ownership of the notebook system. But regardless, this is still an amazing tool. Amazingly expensive, but amazing. All right, so you have SageMaker, right, that you're interacting with a notebook. Anything you would do in a Jupyter notebook, they're inviting you to do that via their suite of tools. All right, so ultimately you're making code commits, you're ultimately making changes to a pipeline. So these are representations ultimately for coding, right, and pushing that code somewhere. Now here you have Amazon ECR, so that is the Docker registry. I'm gonna try to zoom in, you guys are. That's great. That's not gonna work. I'm sorry, guys. Nope. I'm sure there's a smart way to do that. You just got the wrong guy for that. All right, so you make a lot of code, blah, 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 blah. Okay, so ultimately they make it very, very simple to take a model you've built and to push that to the Docker registry via ECR, right? So if you're not familiar with Amazon ECR, that is a very solid way to push private Docker images to your own internal registry. How are we doing on time? All right. Once you have this thing going, then you're able to train your algorithm, right? So you may have done all of this you can do all of this within a notebook, which is pretty amazing. So you can go from just a notebook to slicing and dicing a data set, collecting your data. You can store it on S3, all via a notebook. And then ultimately, they're inviting you to train that very model within Jupyter. So this training algorithm, this is very vague, but you know what this means, right? Whatever estimator.fit, right? So that's ultimately, this is a one-line thing that has a lot of complexity in terms of its infrastructure, but ultimately, you're saying .fit. Now, in this very simple example, I say simple, it was life-changing at the time, but style transfer, they have the Cocoa data set. Notice that Cocoa data set lives on S3. So if you're not familiar with the Cocoa data set, it's a Microsoft data set that has a lot of descriptions of images, basically image captions and the like. So notice here, this Cocoa data set's being trained. Where does that Cocoa data set live? It's on S3. And you may have CloudFront if you want to use that too. So when you have trained this thing, ultimately, let's make the assumption that you have now trained a model, and you're going to make this available, what they call here SageMaker hosting. And ultimately, that means a RESTful API endpoint. So they have a heavy focus in the Amazon documentation on endpoints. They make it stupid simple. It's probably the simplest way I've ever seen to deploy an endpoint including the EC2 instance. And the way you would interact with that endpoint is via API gateway and AWS Lambda. That is one way. You can do this from a Python script. Python script is completely outside of Amazon. You just have a Python script using their SDK can hit these endpoints very, very easily. Okay. Yes, sir. Sorry, Jacob, machine ready for what?
So Lambda could work.
Mm-hmm.
Lambda typically you just write a script somewhere and you send a request and this script Lambda invokes the machines for you,
Yep.
runs it and gives you back a response to request and you pay only for the few minutes, seconds that this request takes and you pay billions of requests.
Yep.
You also don't pay for the time that
Right.
this happens. Is it the same thing? Here you have to actually have a
Yeah. You're asking probably one of the best questions that you can ask when you're thinking about this. So ultimately what Jacob was saying is Lambda is not on demand. It's just It's based on invocation. So a Lambda function, if you're not familiar with it, is a very tiny bit of Python code that can run at any given time. You don't have to have a node running full time. It's a block of code that will run at any given time. Contrast that with the SageMaker endpoint. The instance has to be running, right? And so these things are at odds with each other. You have a Lambda function that can be called, invoked at any given time, which doesn't require a node running, and you have a SageMaker node that needs to be running. So what people have ultimately done is they've created two Lambda functions. The first Lambda function is to launch the the SageMaker endpoint, right? And the second one is to call the endpoint directly via, say API gateway, right? So there's two Lambda functions. One to actually call, is this the cat or a dog? And the second one is to launch the instance. But it's one line of code now via SageMaker to launch this instance. Yeah, that is a great question. In my experience thus far, it's probably, I didn't time it, but I'm gonna guess, somewhere between 5 minutes. It was as fast as 2 minutes and as slow as 10 minutes to launch one of these SageMaker instances. Yeah, you would have to really do some balancing here to say, okay, I have a bunch of requests coming in, I'm gonna have to queue them up, but while they're in the queue, I'm gonna have to launch my SageMaker instance. I mean, the reason you would do it is to control costs. Yeah. Oh, yeah. Oh, you're exactly right. I completely forgot about this. I'm just going to repeat exactly what you said. So there's something called elastic inference, which works similar as a Lambda function, doing effectively the same thing. Thank you. All right, so let me show you a couple of things. So let's say you were wanting to. So I have an instance running, and I'm not going to prove Jacob right. It does take a while. Where I am is if you go to the Aws Console. Oh, thanks, man. All right, so here's my Aws Console. This is my personal one, right? So here's my name. So hopefully you believe me. Here's SageMaker. All right, so I click this thing, and this is the screen you're presented with. So this is I took a screenshot of this earlier. So let's say I want to launch a notebook instance. It's already 7:55. All right, so I'm going to create an instance here, and let's call it Ramy Meetup Demo. It's pretty simple to do, and this is the elastic inference thing that you were alluding to before. So this instance type, these are very similar to EC2 instances. Let's say I want it to be 2x large because I do want it to have a little bit of speed, a little bit of memory. I'm going to ignore the elastic inference thing. Yeah, kind of. It's like a Lambda function, but for a model that's been built. I'm sorry. I must have missed your question. That's a good question. These are not GPU enabled, so it's not going to be like the notebook instance is not. Everything else to train and deploy, those are GPU, or can be. Oh, no, I was lying. I just needed to scroll down. Here's your accelerated computing. I was wrong. There's your GPU stuff, right? So just to save my own cache, I'm just going to do notebook instance type. It's as simple as this. You can do this from the command line if you'd like. Glossed over the IAM role that was right there. And you see this pending thing. So this is the thing that got me. Because pending, it just says pending for a while. And it's not as easy to query what's going on here, right? So this thing may fail on me. I've already had it fail on me twice, where you create the notebook instance, it just sits there, and then eventually you'll get a red error here, but you only get it by refreshing the page, so it's pretty annoying. But let's assume that I've already done this. So this is what happens when you click this instance. So notice this is just a standard Jupyter notebook, right? Nothing special, but it's not just a Jupyter notebook, it's a Sage Maker notebook. Remember, they crossed that out. One quick detail. So this is probably what got me. Can everybody see that? So this is the Sage Maker SDK is on PyPy. Version 1.39 screwed up everything. People were freaking out on. Notice that it has problems. It's a link to GitHub. People were freaking out. I might be exaggerating just a little bit, but I was freaking out. And so ultimately they did a quick fix, probably within 2 hours of the issue being noticed. They pushed, and it's great. Just wanted to make sure that was installed. Okay, so one quick thing, my fault. Where the heck is this thing? Apologies. I git cloned the Amazon SageMaker examples, and that's what you're looking at here. All right. So I'm going to overwhelm you, like they do, with all of the documentation, all of the examples that they provide. All right. So here you see a wide number of different scenarios. This is all in one giant GitHub repo. And the one thing I want to call your attention to is AWS Marketplace, like we talked about before. I'm not going to click into it, but there's a few things in there. They show you how to do hyperparameter tuning for whatever framework you would like, including Keras, MXNet, TensorFlow, R, roll your own, bring your own, XGBoost, etc. They are really trying to tackle the whole darn problem. What we're going to look at is introduction to Amazon algorithms. So blazing text is some, not necessarily proprietary, they published, but Amazon came up with their own version of doing some, they call it parallelized word to vec. It's just insanely fast, right? Why would you use Amazon? Because it's fast. The one I'm going to focus your attention on is something that's very near and dear to my heart, is time series. And what I want to do is not walk you through time series per se, but I want you to see a little bit about the API. And this is crazy to render. Let's see if I can. Okay. All right. So this is one of the notebooks, and I've actually killed a lot of the documentation in this thing because there's so much documentation. It's pretty solid. So this is a lot from Amazon. So notice here, DeepAR is one of their proprietary oops. It's not proprietary. I keep using that word. They came up with their own algorithm because they really wanted to say, if you were trying to do time series forecasting, they just want you to upload all of your data to them, and they have one of these models that will learn the nuances of your time series and make a forecast if you have some new time series, right? It's as simple as that. The example I'm going to show you is kind of cutting to the chase here. We're running out of time. Let me show you what this time series looks like. All right, so this is synthetic time series. Notice it's sinusoidal. And so you're seeing that there's a little bit of noise added to this thing. I'll just plot a handful of time series so you can see the general pattern here. Okay, so these are a handful of things, and there's a giant list of these time series. And notice how the scale of these things are different. So the first one was between, say, 1.5 and 5.5, and the y-axis changes, and so does the x-axis, I believe. So you're seeing a wide variety of these time series, right? So the giant list, let's see. I forget how many time series are in here. I think it's 200. Yeah, 200. Okay, so there's 200 time series in this thing, and so what I'm going to do is I'm going to ultimately what I'm wanting to say is, okay, at a given time, what is my forecast? Or if I already know, say the first 500 points in this time series, what is 501? What is 502? What is 503? Okay, and so notice here, one of the ways you could do a time series, a training test split on a time series is to say, okay, I have data through a certain date. So notice here is January 1st, and this is high resolution, high frequency time series. And notice how we go from January 1st through January 15th. Everything in this orangish color, hopefully you can see that, is going to be what we call the training data. And everything in blue, that's what I'm going to forecast in the future. Now, it's synthetic data, so it is going to be fairly straightforward to get this right, but the goal is to show you how to use the tool, not to impress you with the algorithm. But this thing is pretty accurate even for some of the other stuff. All right, given that we're running out of time, trying to figure out where I can jump to. What's that? It is a deep learning model, yeah. Yeah, they published it maybe a year and a half ago. Yeah, generally speaking, time series doesn't get a lot of focus, but it's probably one of the most important of the machine learning problems. And people focus on cats and dogs, not, yeah. Okay, apologies, I'm kind of jumping ahead here. All right, so if I'm going to train a model, I told you earlier, it's very simple to make it one line, but like when you break it down to all of its individual arguments, it's actually quite a few lines, but you get the point. All right, so I have a session going on, right? I launched it at the beginning, kind of skipping through. Image name here is a Docker image. So just so you can see it. And this is where, right, so notice here there's this ECR registry, it's a link to that thing. So this right here is where the marketplace comes into play. So if you are going to be on the marketplace and you have your own algorithm you want people to use, ultimately you're going to use that image, and there's probably permissions and such related to that. All right, so let's assume I'm going to train this model, and I'm going to specify, again, this is one line of code, one method that's going to launch my instances. How many do I want? I want one because I'm doing this on my own time. What is that instance type? Nothing too fancy, but I mean, it's a sizable one. There's this name going on, and where am I going to write everything? So I have created an S3 bucket called S3 : Aws Sage Maker deep AR. Oops. Ah, crap. Turtles all the way down. Okay. So ultimately what's going to happen is I've already pre-trained this in a very Martha Stewart-like way because it would take a while to train this thing. But ultimately what's going to happen is there's this estimator created. Under the hood, I believe this is a TensorFlow model. So a TensorFlow model is created, and you have this thing called a model bundle. And notice it's just a tarball, and this is just a bash script that I've written, or just command line. Not script, but you get the point, the command. And here's the S3 path to this guy, right? That is the raw artifact here of my model. And so what do you do with this thing? Well, if I wanted to if I wanted to create a new model based on that thing, I can come over here. And of course, you can do all of this via code as well. All I have to do is create a model. My model name is Jacob because he's sitting in front of me. And all I have to do is type in my path, right? And I do this, and what ends up happening is it's going to launch an instance with that very thing, with that model, right? And I'm going to have some endpoint sitting in front of it that's waiting for requests to for that model. Okay, so how do you interact with this thing? Ultimately, you're going to train. So here's a variety of hyperparameters. These are very algorithm dependent. This is time series, so ultimately you're specifying the frequency, so basically how many hertz in this situation, and I believe it's, 60 hertz. So quite a bit of data. I might be wrong there. And ultimately you're specifying a few things, in particular this likelihood function, which this is within. Just consider these as hyperparameters for that time series. So coming back here, I have this estimator, right? They've made this super seamless. I don't have to think about anything in terms of infrastructure. I don't have to think about whatever. Of course, I got to go through the pain of setting up IAM roles and all that nonsense. But once you do it once, it's very, very straightforward, right? So all I have done is I've launched my instances and the like. I'm going to send it my set of hyperparameters, right? So if I wanted to search over an array of these hyperparameters, I just specify it here. I'm going to set those hyperparameters, and then ultimately I'm going to call .fit. Now under the hood, if you're familiar with Bayesian optimization, so ultimately what they are doing, if you're not familiar with that, you may be familiar with something like grid search or random search, like a random search CV, grid search CV. Out of the box, you actually get Bayesian optimization, and it's actually doing a very, how do you describe that in a nutshell? A very smart way of identifying what the optimal hyperparameters here. Now, this actually takes a bit of time to train this thing, but notice here you have standard log messages, and I'm not going to go through it, but this is just being written to the Jupyter notebook. So ultimately, what they're trying to get you to do is not use the command line, is to use Jupyter, right? They want you to use, well, excuse me, not a Jupyter notebook, a SageMaker notebook, right? They don't want you to use the command line. They don't want you to use anything. They just want you to use this notebook. They're writing all the standard out and standard error logs right here to my notebook, right? And my model's trained. Now, when I actually run this thing, I'm going to show you what happens because hopefully it doesn't screw it up. So notice here it says starting the training job, and you're going to see something about an instance running. All right, instance launching. Or not. So is this thing fast? It's never quick to launch an instance on Amazon. All right, so we're just going to jump ahead. All right, so there's not much code here. Right? That's the point. We're basically done, right? So there was this algorithm that was already defined. It was given to me via this Docker image, right? And there are hundreds of these things, right? And so what I'm going to do is that estimator that I had, I'm going to get its job name. So what is the job name? Ah, crap. Interrupt. Okay, so this was the job prefix I had earlier. And so this is really my only variable. This is the way that Amazon is versioning models under the hood. So they're doing all of that pain for you. And I'm going to now create an endpoint from the job. Just like before, I'm going to say how many instances and what type. And the way I'm going to uniquely identify this model is via this job name. And then, of course, the image name, which is the Docker image, right? But that's got to be redundant, because I think those are, I believe that's redundant information, but still, right? And so what this is going to do ultimately, and this actually takes a while, when you run this thing, it's going to launch this instance, and you're going to get a dash, and every few seconds you're going to get a dash, and eventually it's done. And so you see the endpoint name. All right, so I've now trained this model. I've deployed it. I have an instance running called an endpoint, and now I want to interact with it. So this is how good the documentation is that Amazon has created. And I don't say nice things about Amazon very often, but man, they have crushed it here. So not only have they added a huge amount of documentation, but they've also created these helper classes that make interacting with JSON very, very seamless, right? So ultimately what I'm going to do is I'm going to send it another time series as JSON, but I'm going to have to encode that in a JSON format. So basically I'm going to go from a pandas series to raw JSON. I'm going to interact with this endpoint via that JSON. It's going to return back raw JSON, and then I'm going to decode it, right? So Amazon was quite nice to do all this for me. Right, that's what made this really, really simple to do. And you can see I've actually been playing around with this. They gave me a lot of code. They gave you a lot of code if you're willing to spend the low price of $2,000 a month for full deployment. Okay, so what's that? Yeah. Okay, so let's see what this thing looks like. All right. So ultimately, that class we looked at, you are only interacting with this guy, predictor.predict. And so I'm going to show you what one of these things looks like, because this is all I'm sending to that endpoint. Oh, I was wrong. Okay, so it's every hour. I was thinking of a different application. So this is hourly time series, right? So this is a pandas series, right? That's every hour, and here's my randomly sampled measurement, okay? So this is just a giant time series for a single observation. And what I'm going to do for that individual thing is say, okay, what is the forecast at the end of that time series? Now, of course, I'm going to do this in batch. I'm not going to send one time series at a time. I'm actually going to send 5 of those simultaneously. Right? And let's see what the output is, right? So in blue here is what I have inputted as pandas series. I've encoded them as JSON, sent them to my instance, and then what has been returned back is this orange prediction, as well as confidence bands. 80% is the default, I believe, or maybe I specified it above. There's some confidence interval for it. That's just straight from this algorithm, which under the hood was TensorFlow, right? So it was very, very simple. So I know we went through a lot of things in terms of what does it do and the like, but part of the reason for that is I want to, again, screw something up, is show you how straightforward this is, right? Just to repeat, I created my estimator, which ultimately has my training instance. That's where I'm going to be training. I only had one node. Everything was launched for me. I don't have to think about anything, right? Other than how much money do I want to spend, and how I'm going to specify how much money is how many nodes and how big, right? There is a little bit of bookkeeping you have to do. I did create these S3 paths, these buckets up front, but that was pretty simple. Once I've done that, I have these hyperparameters. I'm just going to say train. Just look across a variety of things. This algorithm in particular, the way it trains is pretty interesting. But the bottom line is, here are the hyperparameters. Make a fit. And so I call this .fit. And I send a little bit of metadata in terms of where's my training data on S3 and where's my test data. And then I say, okay, now that has been trained, create an endpoint, right? One line of code again. I mean, like this, yeah, you're paying for convenience. This is pretty amazing. And then again, you're calling predict. All right, so what I want to do is show you what the actual, what the request looks like. Okay, so when I was talking about the JSON blob, ultimately this is what I'm getting back, the raw data I'm getting back from the server, and I'm going to turn that into a variety of pandas objects. And one of those things is just a bunch of individual time series that I'm getting back. One of these is just the indices of what did I actually send in. And finally, what are the predictions, including the quantiles, right? They took care of all of the heavy lifting for me, and like I told you before, they encoded everything for me. And then I send that in, and I have my forecast. And you can see this is a fairly simple forecast. You have fairly high resolution data that has, it's stationary, but you can see not only do you get accurate forecasts for a simple toy problem, but you get confidence intervals. And then the most important thing is way down here, delete the endpoint. Don't forget to delete the endpoint, because that instance is running and you're paying for it. I'm paying for it right now, but I got a cheaper one, so it's okay. Okay, so hopefully I've introduced you enough to SageMaker that you're least intrigued by it, right? There's a lot of documentation, and I can't stress that enough. I was overwhelmed with documentation at first. Most of Amazon's documentation is terrible. They get into the weeds, and you don't know what's going on. And then you master the documentation, and then you become like a AWS black belt or something like that. I don't know what they call you. But the bottom line is it takes a while. This documentation is very, very different. It's much easier to get up to speed. I'm actually going to be, so in the past, so I have a YouTube channel that I haven't kept up to date. I'm having a lot of fun with it, so I'm actually going to create some videos around this stuff. I'll throw these up into that channel over the next few days, probably maybe this weekend. And also, I have a blog that I kind of come in and out of being active. I'll add some notes there, right? So if you really want to see, like, go very slowly, click, 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 look forward to those videos. But I intend to double down on this very thing. And then just to stress, I've seen people take pictures. I will be posting these slides tonight, maybe early tomorrow, very soon, bottom line. And feel free to click the links, look through things yourself. We're quite a bit over time, so apologies about that. But any questions? Yeah.
So can you have like on the notebook side, have about one, since you have to have notebook section,
Mm-hmm.
have you tested, is it possible to have section to one endpoint? Like, you know, it's almost like multiple linear.
So what you're describing is witchcraft, but I understand what you're saying. She's ultimately saying is, can you have different parts of your notebook point to different endpoints? The answer is yes. The standard complaint about Jupyter notebooks is it's going to be difficult to identify what's in session and make sure that the cells have been executed in proper order. See Twitter if you don't know what I'm talking about. But the answer is yes, ultimately. You could do that. There's no reason. So at the end of the day, everything there's an index on all of these. So ultimately, if you can keep the indices in order, this endpoint name, right? That's the only thing you need. Excuse me, that and the name of the Docker registry, that register in the registry. If you have those two things, you can interact with one of those within a certain block of cells, and you can be interacting with another endpoint in a different block of cells. All you need is that endpoint name as well as the Docker link. So the answer is yes. Yeah.
What about reproducibility? And I think this question some cases, for example, talking about Tensorflow or something like this, it doesn't guarantee that the models were reproducible. Some cases they say that you can add Python code to actually set things up, like randomizing and stuff like that to keep it such, but doesn't really work that easily. Do they have any claims over reproducibility or leave reproducibility to the modeler?
So the question is, what does SageMaker Amazon say about reproducibility? Ultimately, their answer to you from a marketing perspective is going to be, you can do whatever you want. If you look at the very top of this notebook, and this doesn't answer your full question, because I'm all too familiar with this nuance. Notice here, I have a random seed set. So any of the data generation is going to be taken care of. But your real point of what about the models, right? This is the data generation side for reproducibility, because it's synthetic data. What about the model side? Ultimately, under the hood, you're using a TensorFlow model, Keras model, scikit model. Scikit models, you can lock down random state, and those are reliable. TensorFlow, Keras in particular, everybody, I've seen several people in the audience kind of doing this. You're basically, it's not about a SageMaker thing of reproducibility, it's the underlying framework. So if you're using TensorFlow and you can add reproducibility, whatever that means, because that's kind of complex. If you can achieve reproducibility with TensorFlow, you get it for free with SageMaker. That's ultimately the answer, which is, yeah, they're taking credit for everybody else's work. Jupyter, TensorFlow, whatever, yeah. Yeah, so let me summarize what you're saying. Ultimately, so this gentleman here uses Google Cloud instead of Amazon. He was using some version of Google Cloud API to launch his infrastructure. They made a change to that code, didn't tell anybody. Now that code has a different behavior. Does SageMaker have a different, does it do something different? So I would say first, you're asking a good question, but let me give you the answer you're not asking, to a question you're not asking. In that situation, I would use something like Terraform or something else to manage that infrastructure. So like Terraform basically is going to be some kind of configuration that will be, it's an open source project that supports Google Cloud, Amazon, Microsoft Azure, all that stuff. So that's my recommendation to you. What I don't know is a question you might ask, how does SageMaker fit into the Terraform world? I don't know. But I suspect it's fairly straightforward because at the end of the day, this is just cloud formation kind of config similar to your Google Cloud. So under the hood, there's very complex JSON configuration for all of these servers. And the reason why this tool is so useful is because the Python SDK just basically abstracts all of that away. You're asking a great question of how do I know that the Python SDK will have the same behavior in the future? I don't know other than pinning a version or something like that. Because the SageMaker SDK does have a version on PyPy. So I would lock down that, that version. But in general, I'd recommend using something like Terraform that'll allow you to not have these issues you're having. Yeah.
During the training phase,
Mm-hmm.
what features does SageMaker have around tracking the experiment, such as this is my data source, this was the results from this experiment run, and we had to tackle the last 10
That's a great question. I'm glad you asked that because I kind of glossed over that. So ultimately, I'm going to take a step back and I'm going to get to that very point. Okay, so when I train a model, ultimately, let me back up here. So I can look at all of the jobs I've trained. So so this one, it says I trained 4 minutes ago. That can't be possible. It's got to be out of date. I did it earlier today. Yeah, whatever. It told me I trained it. Oh, yeah. Okay, see, it's hard to have common sense when you're up here. Okay, so I had some training job that I had running, right? And I want to inspect it, okay? So let's start with logs, because logs will be the first answer to your question. And where you pipe these logs may be a second answer to your question. All right, so about this training job, ultimately this training job, let's be specific here, that .fit code that I had, this .fit right here creates this training job, right? So over here, I have this training job with a lot of metadata around it. So many seconds, here's my ARN, et cetera. And I can view history, here's the image that was used, right? They are logging every little thing. And these are all the configurations that I specified earlier that we briefly went through. But to answer your question more specifically, notice here there's a bunch of monitoring, right? So let me start with the logs, and then we'll look at a couple of other things. So when you look at the logs, ultimately, this is Cloudwatch Logs. And by clicking this, it will begin to answer your question. It's not going to answer your question fully, but you'll start to see what I'm talking about. All right, so these are just standard out kind of logs, summaries from the individual algorithm as it's training, right? And as I scroll down here, what you're ultimately seeing, this is not rendering very well because I'm zoomed in too much. Apologies if you can't see it very well. All right, so notice here in like a very standard way, you have your epoch and you have your loss function here. Notice how I have loss, these things are being logged, right? And so those metrics are being written to disk in some form. And the question is, can you capture them really to monitor am I converging and all of those things? So the first thing is they're written to logs. That's first answer to your question. Second, let's see. This may be the one I killed. That's probably what's going on here. Let me try one more, see if I can do that. The short of it is it shows up there. Well, they tell me it's supposed to show up there. Whether it shows up, I don't know. Add to graph. All right, I don't have a good answer for you. Yep. Yeah. That's a great question. I don't have a good answer for you. I haven't gotten to that level of familiarity with this. Ultimately, the question is, just to repeat it, is I have five different models I'm building, 5 different experiments, and I'm asking the question, which one was best, or is there certain characterization of one that I can learn from the others? How can I see the results simultaneously? I don't have a good answer for that. There may be tools that are out there. I don't know, but at minimum, you should be able to import those logs. I don't know if there's a good tool. One thing to note, though, is you can look at, there is TensorBoard support under the hood. So if you are using something like TensorFlow, you can get at a TensorBoard type visualization. So probably have time for one more question, and then we'll move to CU29. People are starting to leave, so yeah. Sorry. No, go ahead. Mhm. So the answer is yes. Okay, so this model bundle here, I just had it just in case somebody asked this question. So here's this model.tar.gz, the tarball that was produced by that model build, right? So all I've done is I've downloaded that and unzipped it. So and you see quite a few JSON specifications, parameters, and depending on, so ultimately these model bundles are just that raw estimator, either whatever framework it is, right? Because they're trying to be framework agnostic. TensorFlow, Keras, or I guess Keras is TensorFlow, but PyTorch, I didn't mention PyTorch, but they support PyTorch. Scikit, XGBoost, all of those. The model bundle just includes whatever core pieces are necessary to load that model. So like if it's a random forest, it can be the decision trees, some object that includes the decision trees, right? So within these model bundles, you'll have a variety of metadata. So to be a little bit more specific here, so what I can do, so here's, say, the config for that guy. And so I have this nifty tool called JQ. If you haven't used it, it's pretty sweet. But here's what that configuration ultimately looks like. I'm not going to go through the details here, but ultimately, these are the hyperparameters and the variety of the very low-level specification for that algorithm. So they're serializing everything. So at the very beginning, I mentioned that at Novi, where I work, we serialize the heck out of everything. They're doing everything as well, but they give it to you for free. Well, for $2,000 a month, but ultimately, it's included, right? So what we spent all this time doing, very expensive developers doing, they give it to you for cheaper. Yeah, hopefully that answers your question. All right, let's go to CU29. I think there's a little bit of pizza left. So if you want some pizza, please take it. If you don't want some pizza, please take it. Really appreciate you coming out. I learned a lot, so hopefully you did too.